Hey everyone, Miss Kline here. And today we're going to go over activity 1.3 in the unit. And as always, we're going to open up the Project Lead the Way website and read the information in the unit because there's always some wonderful information and background in here. And the topic of this unit is to learn more about the microbit and the make code environment when we're programming the microbit. So we're going to do a little bit of a scavenger hunt, learning where the blocks are we need for coding and what drawers that they are in to look for them. But first we're going to start with the notebook, because remember the digital notebook is where you need to do all of your work. This is where Ms. Kline will see what you've been working on. So to start, what we want to do is learn how to draw something in the grid, in the LED grid. So we're going to open up this link here for the LED grid practice. And Ms. Kline's going to go through this pretty quickly. Remember to stop the video at this point so that you don't see what the answers are, not because we don't want you to practice, but to let yourself challenge yourself. And if you don't know, you can watch the video. Plus, you're going to go through and check through and you'll see at the end what the answers are. So this is just a learning process. It's not a test or something. So we're going to take 0, 4, and just like plotting something in math, we're going to plot it on the coordinate plane here. But unlike normal plotting, we're going to start with 0. So we need to pay attention to that. So x0 and y0. So you can see 0, 1, 2, 3, 4 on the y and 0, 1, 2, 3, 4 on the x-axis. So we're going to go to x is 0, y is, excuse me, x is 4, y is 4. And x is 3, y is 3. And x is 2, y is 2. And x is 3, y is 4. Now we don't have any numbers. This gets a little more challenging. So we're going to remember how we count. X is 0, 1, 2, and y is 0, 1. And remember counting again. X is 0, x is 1, and then y is 0, 1, 2, 3. In this example, x is 0, 1, and then y is 0, 1, 2, 3, 4. In this example, x is 0, 1, 2, and y is 0, 1, 2, 3, 4. And in this example, x is 0, 1, 2, y is 0, 1, 2, 3. You're going to check your answers and you'll get your answers. Please don't worry about your score. If you want to go through and check your incorrect answers and take it again to get a perfect score, that's fine. But as long as you understand the concept, that's the basic idea of how to program an image, which we're going to do in a later unit, in unit 1.5. So we take a screenshot of that and we're going to put that screenshot right here in our notebook. And you're good to go. So the next exercise is the scavenger hunt, as we talked before. Now, Ms. Kline is just helping you navigate your learning. This isn't a test. This isn't to quiz you or anything like that. But as you're learning, where would you find addition and subtraction? You can look over here in the example. Remember, if you take your slides and you fit them, you'll be able to see the things that Ms. Kline's put on the side of the document. And so we're trying to find where you find the addition and subtraction. And you might guess math, and you can look here at Ms. Kline's answers and say, yes, you can see that. In your notebook, obviously these answers are blank, but you know that you can use your neighbors or Ms. Kline as a resource. The other place we can look is in the actual make code microbit environment, and we will just start a new project. It doesn't need a name while we're testing out the drawers. And we can see, I think addition and subtraction will be in the math drawer. And there it is. And another question, it is, where is the button A? Remember, putting its input. We're pushing a button to give input. And there it is, button A. And what notes C and G sound like music notes. We can look in the music drawer and you'll see, yep, there it is. So there's different ways for you to learn how to answer these questions here. And again, you always have Ms. Kline's help as well. So you're going to do those 3 pages. And then the next section, we're going to learn how to flowchart the blink. So we want to program an LED to blink on and off. And remember to stop the video, try it yourself in your own notebook, and then you can watch the video to get some help here. but you're going to start the program with a forever block or a repeat loop. These are your loops. Then you're going to show LEDs showing the pattern. So maybe there'll be a smiley face, and then you're going to have an LED block with no pattern. So that'll be blank. So it's going to flash on and then look like it's flashing off, but it's really just flashing a blank screen. The next thing you're going to do is you're going to flowchart, and you're going to create a flowchart just like Miss Kline did. You can see we started, we added a loop, we had an LED block with an image, smiley face, whatever, an LED block that was blank, and then end. So the starting and the end of your flowchart are always ovals, and the effects that you're doing are rectangles, and then you want to have the arrows. There's an easy program. You could use Google Draw, no problem, but we're trying to teach you a new tool. So we're going to click on the Draw IO. It's a flowchart maker. You can save it on your device. You're going to create a new diagram, make sure it's blank, and create. It doesn't matter where you save it. You don't need to name it anything because we're going to take a screenshot again. So we're going to just drag a start oval. We're going to grab a finish oval. We're going to grab arrows. Some people like the big arrows. If you want that, that's fine. You're going to grab that arrow and turn it down. It's going to be a little awkward and you're going to make some mistakes, but that's okay. Click on that arrow and Control-C and Control-V to paste it. You're going to need a few of those. So just Control-V to paste it again, or Edit Paste. So we have plenty of arrows now. Now we're going to grab the oval rectangle, the rounded rectangles. So we're going to write start. Then we're going to use a loop block. Could be forever, could be repeat. We're going to grab the next block. We're going to LED block with image. That could be a smiley face, something else. And this is an LED block. No image. And I don't normally capitalize things, but that way we can see there's no image. And that's it. It's done. So we're going to put our arrows there. And our next arrow. And our last arrow. It's kind of nice because all the arrows are exactly the same size. We're going to put the word stop. And that is our flowchart. So we're going to take a screenshot. I just need the whole flowchart in it. And we're going to drag that flowchart right here and put it into our image. And I'll do the new one we just made. And you're done with your flowchart. The next section is already a video for you, and it'll help you program the blink. And it teaches you how to download the hex code that you need. You'll be downloading a hex code right here. You'll click on it, click on the link, Control click or Alt click on a Chromebook. If you open it in a new tab, it'll download the code for you. Then you're going to open up MakeCode microbit again. And you're going to import that code you just did. Import the file, choose the file. It's in your downloads. The file was called Innovator. Now we're going to look at that code. And you can see when you press the button A, it's going to do this 4 times. Check X, check X, check X 4 times, and then it'll end with a clear screen. If we press button B, we're going to have a loop 4 times. Big, medium, small, square, clear screen 4 times. But instead of stopping with the clear screen, this time it's going to finish with a solid LED image, which is the smiley face. So back in our notebook, we're going to say what we saw when we press button A, what we saw when we press button B. Same thing with the maker hex. We're going to do the same thing again. We're going to Control click with a PC or a Mac, or hold down the Alt key with a Chromebook. First, we have to open that website there. Now Control click or Alt click and open in a new tab. It downloads the maker hex file for you. Once again, you're going to open up the MakeCode emulator. We're going to import that file we found. Import, choose file, maker is the name of that file, maker.hex. Hex means a code that'll go into the MakeCode arcade emulator, and you can upload it into your actual microbit. So this time when we press the A, it's reversed. It's going to do the X, then the check 4 times. And when we press the B, it's going to do 3, 2, arrow 4 times and end with a smiley. So it's a little bit different. I would like you to practice uploading those files into your MakeCode emulator, and you'll learn how to do that in a real microbit when we meet in person again. So back to our notebook. We're almost done with this whole unit. You're going to write that down, what you saw, and then your conclusion is something that you've learned on your own. When it's necessary to code, why is it necessary to explore and understand the coding environment before you start coding? So why do you want to know about all those drawers we taught you about? And then why do you think computer scientists need a flowchart when they code? How would that help them? And then the vocabulary, as you remember before, this kind always has a link to your vocabulary. And then the words that you're defining, for example, emulator, we're going to look it up like a grown-up would. We aren't going to write sentences because you're using these words in your programming, but in this situation, we're learning to look it up like we would if we were an adult reading a book and we wanted to look up a word. So we'll find there's emulator. You can highlight it, Control-C to copy it. When you paste it in here, you want to do a Shift Control-V or Command-V. A Shift Control-V will make it put the letters exactly the size that you want them. If we did this without the Control-V, it would be small. So we want to do a Shift Control-V, and then it'll paste it full size. So great job, everybody. That's the whole Unit 1.3 all in one quick video. Again, I did do the video before for the emulator uploading the hex files, but you can see it all in this one single video. So great job, you guys. You got this.